This is CIT 1121, Module 7.2, Ethernet MAC address. When we talk about the MAC addresses, we're now finally putting some format onto the frame headers and the source and destination addresses. So what they want to get you to learn in this section is that they are 48 bits in length, which is 6 bytes. So 48 bits, 6 bytes. And they're always going to be that size. They are burned into the network interface cards, and those addresses are split down the middle. So there's the first 24 bits. The bits on the left are what are known as the OUI value, the organizationally unique identifier. What does that mean? There's a real easy way we can write that. We could just say vendor. So what does this tell us? Well, this gives us a little information. So if we're getting weird MAC addresses on our networks and we're capturing traffic and we're finding that there's this information that's floating around, and we look at the MAC address, we can look at the first 24 bits, we could identify who the vendor is. And we would then know if that vendor's traffic or information is supposed to be on our network. Because if we're going to go through a secure network, here's the thing. When you think about a secure building, everyone has a name card or some kind of token that will get them around. It's got a picture of them, and you can identify them whenever you want to. The vendor portion of the MAC address is kind of the same thing on a network. It's a value that's carried around. It says, I am information that is posted into this network, and the network interface card that created me was from this particular manufacturer. It could be Cisco, it could be VMware, it could be Dell, it could be all kinds of different manufacturers make network interface information. And that value is the value that you could use to identify if something is not supposed to be on your network, and you're like, hey, I don't remember us having any HP equipment at all. Why are we getting HP MAC addresses floating around on our network? Or weird vendor MAC addresses like 1, 2, 3, 4. That's kind of strange. Anyway, so the left-hand side is known as the OUI value, the organizationally unique identifier. The other half is going to be random. It's just going to be a rando value, and that value is going to be generated by an algorithm that's going to assume or create a unique value with this side over here, because the MAC address on a LAN has to be unique. Now, we have 24 bits to make it unique versus anyone else, right? So if we had 100 computers, and all 100 computers are manufactured by the same organization, and that means that their MAC addresses, the vendor value is going to be the same for each one of those. But we have 2 to the 24th power of bits left, which is a boatload of combinations of zeros and ones, to ensure that we have unique values for those 100 machines, so that they can be identified uniquely as being the only location. And we'll get into that and I always say this, but in the very next presentation, just to make you watch it, I guess. I don't know. But we'll do what's called a CAM table, and we'll talk about how a switch memorizes MAC addresses. And if they're not unique, then it's going to be really, really bad, because you won't be able to uniquely find a device on a network if the second half of the MAC address is not a unique value. So half of it's for the vendor. The other half is going to be a unique value. That's the only requirements of that MAC address. All right, I think we've got the base piece for that. So let's go not backwards, but forwards. Here we go. Okay, cool. All right, so this particular slide is talking about, well, hey, there's some devices that want to communicate on a network, and we have 4 PCs, H1, 2, 3, and 4. H standing for host. Remember, we always like to call our PCs hosts, and then they're connected by a single switch. Now, that switch is going to build a table in the future, but essentially, in this particular case, this kind of traffic is what's known as unicast traffic. And it's unicast traffic, and I know that because if I look at the source address here, let's suppose that this source belongs to H1. And if the destination here value, let's just assume that this is H3, okay? And you can see the little blurbs of the computers talking like they're cartoons. H1 has sent this out with a source MAC address with its burned-in BIA, burned-in address of all A's. Just, hey, we got lucky, right? And then, and this flies right in the face of what we just talked to you about, the OUI value versus the unique 24 bits that follows it. But whatever. So H3 has its destination value is all C's, and if H1 sends information to H3, it's possible H2 and H4 also receive it. They shouldn't because a switch should block that. But in this case, if it's unicast traffic, H1's going to send this in. It's going to hit that switch, and that switch is going to send it down to H3. H3 is going to identify this value, this destination, and say, yeah, that's me. I'm going to keep reading stuff that's over here. I'm going to read the packet header. I'm going to read the segment header. And as long as those things are matching things that I can also do, as long as they match an IP address and they match a process that I can run, I'm going to go ahead and act upon the data that is here, right? H2 maybe received it. H4 maybe received it. But they look at that destination and they go, well, no, my MAC address is bb.bb.bb.bb, so on and so forth. And H4 is going to say, you know what, mine is ABCD, dd.dd.dd. You get the idea. And they're both going to say, this isn't for me. I'm just going to stop reading. They'll just stop reading at that point because it doesn't concern them. It's not their MAC address. If the MAC address doesn't match, then it's not going to be read by a receiving device, with the exception of one other case. So this here, device-to-device, unicast traffic, called unicast. This is what's known as unicast traffic, where we have a one-to-one communication between devices. All right, cool. Let's go through another type of communication, and this time let's call it broadcast communication. Now, here's the thing. And this is something we haven't brought up yet, but we're going to need to get to it eventually. If there's a chance that a device doesn't know another device's MAC address, they're going to have to send out a broadcast message and ask for it, right? So let's kind of go into the same scenario as we just had. This one's going to be A. This one's going to be B. I'm just shortening this down just to make life easy. This one's going to be C's, and this one's going to be D's, okay? Now, here's the thing. A wants to send information to C, or 1 wants to send information to 3. H1 knows that its IP address, and we're going to add some IP address information in here, is 1.10. And C's IP address is 192.168.1.12. Okay? Now, A knows that it wants to send information to device 3 because it knows this IP address. It learned it somehow. Don't worry about how. But it knows this is the IP address it wants to send to. But what it doesn't know is the destination MAC address. Now, the thing is, a switch doesn't read IP addresses. A switch is going to work off of only MAC addresses, which we're going to get, once again, into the next section. Okay? So if that's the case, A has to send out what's called a broadcast message before it can actually send the message that it wants to send. A wants to send C a message, but it doesn't know its MAC address. So what it has to do is it sends out a broadcast message, and that broadcast message is called an ARP message. Broadcast message, broadcast, and I'm going to write ARP right here. Okay, now here's the thing. We send out a broadcast ARP. It basically says this. It says, who is, and then the IP address that you want to communicate with, 192.168. In this case, 1.12, okay? And then in the frame header, the source MAC is going to be, A, but the destination MAC is going to be a very special destination MAC address. And the very special destination MAC address comes up as 48 bits of all Fs. This is what's also known as a wildcard mask. So the destination MAC address of all Fs is a special broadcast address. And it's the only special broadcast address you need to be aware of within Ethernet. This is the only one that's different. Everything else is read the MAC address, forward the traffic to the MAC address where it's at. Well, that's not true. Multicast is a little different as well, but let's not worry about multicast right now. Let's worry about broadcast. So we're going to broadcast this out. I'm just going to write broadcast over here across this side over here. So in a broadcast message, the destination MAC address is going to be all Fs. And this has to go out first. So H1 wants to send information to H3. H1 does not know H3's MAC address. So it sends onto the wire, into the switch. It says, hey, I'm device A, 48 bits of A. I'm going to send this to 48 bits of F, which is going to go to all three of these devices. So H3 is going to get it, H2 is going to get it, H4 is going to get it. And they're all going to read it. They're all going to go, oh, hey, who's this for? Oh, it's a special broadcast. Okay, I'm supposed to read this. This is designed, if it's supposed to go to B's, H2's like, hey, if it's supposed to go to all B's, I'm going to read it, right? Because that's my MAC address. But in this special circumstance, if it's all F's, I read those too. H4 says the same thing. I would read anything that comes in with my MAC address, but I'll also read one that has a destination MAC address of all F's, because this is a broadcast. This is how the technology builds tables. We learn an IP address. We need to get a MAC address. We leverage our knowledge of the IP address to get the MAC address off of the LAN. So it goes to H3. It reads it. It goes, hey, this is my IP address. I'm going to send a response back to device A. A then gets the MAC address for device H3, and then H1 can send H3 the actual message that it wants to send. And this is a good example of how broadcast works. H2 receives it and says, I'm not 1.12, I'm 1.11 or whatever. H4 also receives it, checks its IP address. It's not 1.12, it's 1.14. Oh well, and it doesn't do anything else. So what the broadcast does here is it ensures that if there's information that's needed from the LAN and a device can send information to another device, it can go ahead and pass that out to everybody, and the device that it's looking for will be a responder, and everyone else will just assume that it's part of the overhead. You know what? Me being part of this LAN, part of my job is I got to accept these broadcast messages. Sometimes it's for me, sometimes it's not, but I have to read them, and I have to check to see if they're really for me. Okay? So that's what they're getting into as far as a broadcast message. Remember that special destination MAC field. We'll get into this further when we get into some Wireshark stuff too. All right, now the last slide I want to get into here is what's called multicast. What multicast says is this, is we're going to use another special MAC address. And in the special MAC address, we're going to duplicate it the last possible time. So let's say H1 is a multicast server. And it's passing off some kind of, maybe client, it's just like this class, right? So it's going to send this out to these devices. So H3 is going to say this, oh, you know what? I really want to be a part of that multicast, and it's going to use a special MAC address that is not its own MAC address, but it'll use a special MAC address that says, I want to subscribe to that particular multicast. And it's going to start receiving that stream. So it's going to be one in, one out at this point. Now, H2 and H4, they're like, hey, you know what? I want to watch that too. So they both also subscribe. And now it's one in, but it's three out. It'll duplicate the switch based on those MAC address values of the multicast. It will then it'll take the one in, it'll make the three out, and it'll work exactly as it's supposed to. But then device 4 is like, you know what, I don't want it anymore. And it sends a leave message. Now there's only two. And then H3 is like, I don't want to watch this anymore either. This is boring. And it sends a leave message, and then the switch stops sending it. But then later, device 4 is like, you know what, I kind of like that. I'm going to go ahead and do that again. I want to see that again. I don't know why I can't ever click on this thing. And it'll rejoin. It can send a join message. So multicast is going to duplicate a stream or a data segment for just the amount of devices that are on the device that want that particular stream. So that's a little bit about how multicast works. In the next section, we're going to talk about how switches work. It's going to be super exciting.